Okay, welcome everyone. So welcome to the T2TRG Research Group online summary meeting. So this is the first time we're doing this online. You all know because of why. All the meetings have turned virtual during these times. So my name is Ari Keränen, and together with Karsten Borman, we are chairing the T2TRG Research Group. Quick note, three main points. If everything works as expected, you are being recorded right now. You should also be nice and professional and welcoming to each other. And also the IPR guidelines of the IETF do apply to this meeting. For a more detailed version of the note, you can have a look at the slides and the links here, both on the IPR guidelines and also the privacy and code of conduct. And a quick reminder about the goals of the IRTF. So this is not the IETF, but IRTF, and the Internet Research Task Force really focus on the longer-term research issues of the Internet, whereas on the IETF side, the focus on the short-term issues of engineering and standards making. So here at the IRTF, we are doing research and not a standards or standards as in the IETF side. But of course, we do a lot of collaboration with the IETF on all of these topics. If you want to have more information about IRTF, you can look at the RFC 7418. Quick administrative. So we don't have physical blue sheets on this meeting. However, at the end of the Etherpad, in the link that is visible in the WebEx chat, you have blue sheet and or attendance section where you can write your name and affiliation. I see we have note takers. We have Christian who volunteered. Thanks a lot, Christian. We also have a couple of persons in the Jabber. If you want to be able to keep up with what's happening at T2TRG, the best way to do that is to sign up on the mailing list, t2trg@irtf.org. There's a link also on the slide how to do that. And also, as we have been having on all the meetings so far, we do have a GitHub repository with all the latest information about this meeting and also the materials that are shown and shared here. And the link is on the last line of this slide. The agenda for today, we are right now in the intro part. So we'll give a status update of the research group and also quick update on the upcoming meets and activities. Then we have reports from various T2TRG and related activities from Wishy, work we do with 1DM, and also a quick one on W3C Web of Things. Following that, Karsten will give a 1DM update and tutorial. And then the main part of the meeting is going to be on the Lars Egert giving a presentation about Quick and IoT. Then we had 3 presentations about work ongoing at the research group and also the IETF side. So Mohit will present bootstrapping terminology. Tiru will present MUD or details profiles for IoT devices. And finally, Xavier will be presenting the IoT challenges and functions. Roughly that all should be taking about 2 hours before we can wrap up. Any questions or comments on the agenda?
I think as I will not be able to attend the second half of the time here, and that sounds interesting stuff I will be missing, if you could issue the recording link, that would be really helpful.
Absolutely. We'll find a way to share the recording soon after the meeting is over, so you will be able to check the recording from there. And also, quick reminder how on the queue management, since we don't have physical mic lines here, you can at any moment put a Q+ on the WebEx chat and that way get a position in the queue. But since we are not a massive amount of people, and if you feel there's a natural time to chime in, you can also go ahead and do that just like Henk just did. But if there's more ongoing discussion, it's probably easier to use the queue management and just put Q+ in the chat. Or if you need to remove yourself from the queue, if someone, for example, already covered your point, you can also put Q-. Okay, and moving on, quick reminder about the T2TRG Research Group scope and goals. So just like at the IRTF large, we are focusing on open research issues, But in particular, in this group, we are focusing on the Internet of Things and how we can make the real IoT reality. In particular, we often focus here on low resource nodes and how we can bring those low resource nodes part of the bigger internet, part of the bigger IoT. And as we are doing a lot of collaboration with the IETF side, we focus here on the issues that have opportunities for IETF standardization. So we start at the IP adaptation layer and work our way all the way up to the application and architectures, APIs, including management and in particular security. So we work with, of course, many IETF groups. Here's an example of two groups that we have in particular close collaboration with. So whereas we do the research on the open research issues on the T2TRG, for example, in the core working group is a lot of where the protocol engineering for RESTful environments happen. And we have had multiple topics moving between T2TRG and core recently. And then we have in particular another group called ELWIC that is publishing informational guidance about how to implement IoT systems, in particular on the constraint side. So right now we are in a summary meeting. We have these meetings usually during the IETF week, this time, of course, online. And here we, in general, give an update on what has happened between the IETFs, what's coming next for the thinking research group. A lot of the actual work, technical work, happens in other meetings. So what we have coming next for T2TRG is that we have had these regular WISHI work on IoT semantic and hypermedia interoperability calls. Roughly on a monthly cadence, usually on one of the meetings, we decide what is a good time for the next meeting for WISHI. Now we are planning one next Friday, 24th. The exact time is still TBD. We have also had online meetings, commonly with OCF, OMA Spectre, W3C Web of Things. In particular, we had a meetings with OCF some weeks ago about their use of IETF protocols and information and data. Also, what we were planning for a physical meeting with WC Web of Things in June, co-located with the ICWE academic conference. However, that was also now turned into an online meeting, just like all the other standardization meetings nowadays. But you should be hearing more information about that shortly. We are also planning for a topic-based meetings on selected one data model related issues somewhere in the May timeframe. The details are still open. And of course, at the next IETF, depending whether that's going to be an online meeting or a physical meeting, we will have some activities co-located. But we will have to wait until May about the decision if the IETF is going to be physical or online. We also have this long-standing plan to have more co-located meetings with academic conferences. Almost had one now in the June meeting, but unfortunately that was turned into online meeting. But hopefully next year we manage to have something physically co-located with an academic conference. And if you have any ideas what would be a good conference, perhaps you're organizing one, please do approach us chairs for more information. We're more than happy to talk with you. And moving on to the research group document status. Currently, we have published one RFC on security, and we have another research group document in the works right now called RESTful Design for IoT. That one still has a couple of issues we want to have closer for before publishing it, in particular on affordance and discovery. We are now thinking if we should have a design team meeting with the authors and open for everyone else to join too, to really have finally able to close those issues and publish the document. Also, we have upcoming this Edge and IoT document that's going to be a short update coming later today. We are now planning for that to be ready for research group adoption. So, of course, reviewers for that document would be more than welcome. Also, we have secure bootstrapping for IoT document, a short update coming in a moment. There are three other topic areas that we have had discussions a lot, and there are also documents for UP for describing binary data in legacy formats, variety of different core applications, core interfaces, and also layer 3 communication considerations. They are not presented today, but they are topics that we have ongoing work. If you're interested in getting involved, please contact us chairs. We can point you to the right people and right documents. Also, we are planning to make some of the Wishy notes into more formal documents. So in the Wishy work, we have a lot of notes from the meetings. We have been turning some of those into wiki pages so far, documenting our learnings, for example, on terminology and architecture and engineering principles. And we have a plan of turning some of those into research group documents also going forward. Then a quick update on the Wishy activity. So Wishy activity is something that the research group has had for the past few years already. It started with a workshop at the Prague IETF, and then we have been continuing in various forms of physical and physical and online meetings. After the last IETF, we have had 2 online meetings with 2 topics that have been in both of those meetings. One data model has been very much in focus for both of those meetings. In particular, we have been looking at 1DM and how it relates to Web of Things, IoT schema, how these things work together. We have had discussions on how we do protocol bindings from one data model, and also how we build applications on one data model. So how you build a semantic proxy and what should the semantic APIs look like. Karsten is going to be talking about 1DM more in a moment. Also, another bigger topic we have had, it was this data model design considerations, and in particular, how do you do versioning of data models and how do you handle the number spaces of data models? That seems to be a topic that is popping up right now in multiple different fora working on data models, including 1DM. We've been trying to gather some common knowledge and design guidelines for those topics. Then a few words about the Wishy 1DM hackathon. So we had normally we have had Wishy hackathons as part of the IETF hackathon in the face-to-face meetings, but now since the face-to-face hackathon was canceled, we had a virtual hackathon last week. Essentially, it was a 4-hour WebEx session where we started with a show and tell session. So everyone who had relevant implementations could show them and see how they could be made to work together. We had, for example, implements of 1DM and Web of Things, thing descriptions, etc. We also had this proof of concept challenge. The idea was that how could we build this semantic proxy that can work, how can facilitate interoperability between 2 different ecosystems. And the 2 particular ecosystems we chose for this challenge were the OMS SpecWorks Lightweight M2M IPSO and OCF. And the idea was to have an OCF application working through the semantic proxy, only using information that is in the SDF, one data model SDF models, and be able to communicate with a lightweight M2M device, for example, to read a temperature value. During these 4 hours, we didn't quite get to the implementation details. However, we did manage to get quite a bit refined prototyping plan, and we do have a set of components, software components chosen for that. And we're going to be continuing putting those together and be able to actually fulfill this proof of concept in the near future. If you're interested in joining this activity, please do let us know, and we can tell you more about it and show where it's done. Also, before the IETF, we had a pre-IETF meeting. We have had this commonly in the past few face-to-face meetings on the Friday before the IETF weekend hackathon. And this one was focused on 1DM. Again, of course, it was an online meeting this time. Very, very similar topics as we have had in the Wishy calls. So versioning, evolution of data models, and evolution of data model languages were in the focus. And in particular, whether you should use versioning or if features are a better solutions for the same challenges, and how do you can make different versions or revisions of the data models, but also the language. We also did have a session on the 1DM technical issues, and of course, versioning of one data models in particular was in focus, but that's still work in progress. But we are now basing that on the learnings that we have had from various different other fora. Also, the whole topic of events, actions, properties, data definitions is something that we have noticed and needs more clarity, and we have been working on that in many of the meetings, including the pre-IETF meeting. And then given that this meeting was supposed to be co-located with the IETF, one key topic there was this potential for 1DM language standardization at the IETF, but Karsten will be going in more details on that. If you're interested on the details of this meeting, you can check out the detailed notes on the link below. So that was all the updates from T2TRG activities. Before we go for the W3C Web of Things update, are there any questions or comments on the research group activities update? And unfortunately, I don't see the WebEx queue while I'm sharing my screen.
It's empty right now.
Okay, in that case, then let's move on. Do we have Ege online?
Yes, can you hear me?
Yes, we can. Please go ahead, Ege.
Okay. So I have actually prepared some slides quickly. So I'm just putting them in Etherpad. And in case my screen sharing doesn't work. Okay.
Yeah, going to the Etherpad might be a good opportunity to actually enter your name into the blue sheet, because there are some.
I put as number 15.
I'm not talking about you, I'm talking about everybody else.
Okay, all right.
Sorry.
Okay, so let's see. So do you see my screen?
Yes.
Okay, so hello everyone, I'm Ege, and I'm a PhD candidate in Technical University of Munich, and also with Siemens, and I am in the W3C working group on Web of Things, and I mostly work on the binding templates, document, and the testing aspects. So I would like to start with a small recap. So the current charter and what we were working on in the Web of Things working group, we were focusing on these 5 deliverables. So the what architecture is a document that was detailing the different use cases for Web of Things technologies and was giving the formal definitions. So here we see that we can use Web of Things for connecting devices to the cloud, which could be, let's say, like sensors or robots or even like cars. And there it shows what it would look like defined behind some proxies or not, and so on. So it's more of an informative document which has some more normative definitions. I would say the core document or the deliverable we have is the thing description document, and it is basically what we use to represent the network-facing interfaces of things. So, by the way, oops. Yeah. So network-facing interfaces of things. So at the moment, it's a JSON LD document, but it could be represented in other ways. But in the foremost, it's a model. So with the binding templates document, we explain how we can represent different protocols of these things. So if a thing is using HTTP CoAP or MQTT, how would it look like in a thing description document? And instead of JSON, if I were to transmit XML, how would it look like? In the scripting API document, we actually prescribe a scripting API. So how you can program a consumer, so the client applications, and also like a thing implementation. So as you can see, all these documents are linked here to their official W3C recommendations. And lastly, we have the security and privacy guidelines, which is a non-normative guide on how to use the correct security standards. So we don't prescribe on, so we don't like say that you have to do security this way, but it's more like there are these security technologies and you should use them in your application. Okay. Yeah, so as of last week, the April 9th, so since Thursday, architecture and thing descriptions are W3C recommendations. And the other deliverables are W3C notes, since they are more like complementary documents to the thing description and architecture. Yeah. Okay, so that was more or less what has happened until more or less last week. And just for a quick reference, if somebody wants to quickly understand what is a thing description, it's basically this model that we propose where we have like the 1DM proposal, the property, action, and event affordances. And we also have some metadata, human-readable metadata. We have some information on versioning, different language support, and so on. So different security schemes. Yeah, but this is like a high-level view of the model. And what we have more to come is that the working group is going on a small maintenance round, and we are aiming to release what we call version 1.1 of the specifications. So it's basically some small features that were like that we couldn't finish until the release, and some things that were found during the last phases of the standardization where we couldn't change the standard anymore. We have a new task force on the discovery. So how can we use different discovery mechanisms in the Web of Things context? We are working on more streamlined testing. So how can we improve the current testing activity and like propose more online tools for this? And we're also planning some developer outreach sessions where we first show from our side how can somebody develop a thing or consumer implementation, and also would like to invite other people to come and explain their implementations for like developers. Yeah, so this is my last slide. So if you want to have more information about the standards, they are in the second slide, as I shown. We have this main page that gives a little introduction into Web of Things. We have our wiki where you can see the different calls we have, and the minutes of the calls, which are all public. We have a library that groups different Web of Things implementations, so you can go and look at the source code of some things and their thing descriptions. As with any W3C recommendation, we have to have a report detailing the current implementations and how do they support the standard. And currently we have a reference implementation to develop things, so like a library based on Node.js, and it's an Eclipse Foundation project. Okay, so that was all from my side, and I'll be very happy to answer your questions. And if some things weren't clear, just please go ahead. I hope it wasn't too fast, but I don't know how much time I had. So.
Thank you, Ege. That was perfect. I see at the moment no one in the queue. I think we can move on, and if you want to hear more about that, yeah, feel free to reach out to Ege or to us, and we can more than happy to contact you, the right persons.
Yeah, I'll write my email actually. Okay, thank you.
Thank you again. So next we have on the agenda Karsten, and with the 1DM update and tutorial. And just a reminder for everyone, please don't share your video. That will be consuming bandwidth from all of us, and that seems to be scarce at the moment. And please keep your microphone muted if you're not talking or presenting. Thank you. Karsten, go ahead.
So I hope you see my slides.
Yes.
Okay, so this is a really brief tutorial about the one data model activity and the SDF format that is being created there. Michael Costa had a very nice tutorial about this at the Singapore IETF, or actually at the workshop we had ahead of that. I'm not going to try to redo his work there, but I'm going to take a slightly higher level view and try to explain what are the components and cogs and gears and how do they actually fit into each other. So just as a reminder, why is it useful to do this? Of course, it's always nice to have common standards, but really the motivation here is that we have a number of ecosystem-specific standards development organizations in the Internet of Things, and each ecosystem has developed their own data models and their own way to document them. And it turns out applications really have to talk to things, to devices from multiple ecosystems. So there is no chance that a single ecosystem can supply all the devices that may be needed in a less than trivial IoT application. So applications need to talk to all those, to devices from all those ecosystems or from many of these ecosystems. And why building protocol translators is possible, I mean, it's not easy, it's possible. It's actually even harder to translate the hundreds of data models that we have out there for the different devices. And actually, nobody is really making money for having a better data model than the other ecosystem. So it's not really something where people compete. So at some point, people from different SDOs, standards development organizations, noticed this and created a liaison group, which is an informal group of people from these different SDOs who talk to each other. And the idea is to bring together these hundreds of ecosystem-specific data models, express them in a common format, and then actually work on merging and harmonizing. It's really hard to merge data models that are in completely different forms. But once you have expressed them in a common format, you actually see, oh, this is redundant. And our model is actually missing that part, and let's add that, and so on. So this is really the harmonization process, and that is just starting. I think that right now there is a single model where that actually has worked, but that's really the main job here, to look at data models and look where there is potential for coming up with common models. So the whole thing is done in the open. The data models will be available for all. It's a BSD license behind them, so it's completely open source, no strings attached license. And actually, even though the liaison group still is a group of SDOs which are mostly operating under non-disclosure agreements, the actual harmonization work is happening in the open. So you can go to the GitHub repository, one data model, and find things there. Now, I have stressed the need for a common format, and that's what I'm going to focus on for the next 10 slides. So in order to be able to harmonize data models, we need to be able to express them in a common format, and that's SDF. So SDF stands for Simple Definition Format. Usually all standards that start out with the word simple in their name at some point have to lose that word. Well, there is a certain hope that we actually can have a simple standard for once. And there is the GitHub repository where you can look at the current state of development. So you heard Ige talk about the thing description, which is a format to describe a single thing. And SDF is a format to describe a class of things. So things with certain common characteristics. And of course, that's not that much different. So some of the things you saw on Ege's slide will come up on my slides again. And of course, it's all the same people who are doing this work. So there is a lot of cross-pollination here, and we are trying to not emphasize the competition here, but actually the way how these things can work together. So IoT things don't have data, so it's a bit weird to talk about common data models for IoT things. Things have interactions with their peers, and I'm going to use the word clients here. That's not a one DM term because it sounds like client server, and we are going beyond that. But bear with me for these slides that I call the guys who are not the things, clients. So those things offer interactions that can be done, and we call them affordances. You saw on I guess slides, and it's kind of popular to group affordances into interaction patterns. So right now we are talking about property, action, and event patterns, and I'm going to go into those later. And of course, those interactions actually do input and output data, and that's where the real data model part of the SDF model come in. But you have to have the other parts, the interaction part, so that these data models actually make sense in context. So let's talk about those interaction patterns. Property, action, and event. And actually, most protocol environments have something like that. And because people may be familiar with REST, I put in a column here that has the REST name of that interaction pattern. And I also have a column that talks about the initiative. So who's actually starting this interaction? And the final two columns of the table show what kind of data is actually processed while performing this interaction. And typically you can talk about input data and output data. So a property is like something that is like a REST GET affordance. It can be initiated by a client, and it gives you some output data. But there are also writable properties, which are properties that also allow a put interaction, so that there are two different interactions provided by the same affordance here, if it's writable. And of course, the idea is that a property put or set actually changes something that is used by the thing to do its work, like a temperature set point or color or something like that. The second group of interaction is the action, which is pretty much a remote procedure call in the view of many people. In REST, we have the post primitive for that. The initiative, again, is with the client, and there is input data and output data. And these input and output data are different, because it's not just setting a proxy here, a property here. It might be something like starting a process, making a coffee or something like that. So the output data, of course, on the physical side will be the coffee, but on the side that we model here will be the fact that the coffee is done and maybe some additional information about it. And finally, there is the event, which is something that is not really supported very well by REST. So there are various ways of supporting event style data in various REST environments. The point here is that the initiative is actually with a thing. So in the REST world, that would be the server, and servers normally don't generate initiative. But the whole point is that the event also has some data, which I call output data here, and that is the third pattern. So let's talk about those patterns in a little bit more detail. So the action pattern is sometimes, in some ecosystems, it's the only thing you have. You can send a command to something and you get a response, and whether that was a property right or an actual action in our sense here, that's not modeled. So here we do distinguish properties, which are just data that can be set atomically, and actions which do something, create an output that is the result of an operation, and actually may take some time to do. So an action may have a client initiative to initiate it, but then it may only result in data later. So it's a little bit different from a property which always happens instantly. So this is the only pattern we have where we have two different data models that go into it. So I talked about properties already a little bit. Let me just point out that SDF also has an observable property, like the thing description picture you just saw from Egge. And that's pretty interesting because with an observable property, the initial initiative, again, is with the client. But from then on, it's the thing that tells you that there are updates to this property. And you can see this is actually not much different from an event. So it's not quite clear how where the boundary between these two is. So let's look at the event. That's maybe the least well-defined interaction pattern. But from a data modeling point of view, it's actually easier. I mean, it's not different from a property at all. It generates some output. And from the data modeling point of view, it doesn't make a big difference whether the client requests it or it comes on its own by itself. But there are still semantic differences that we are not modeling right now. Events might be like observable properties, just status updates, so the temperature changes, so you get an event that the temperature has changed. Or they may actually be more heavyweight occurrences where every single one of them is precious. So you might model the insertion of a coin in a device as an event. And then, of course, you need to model the fact that you cannot lose these events. So there we have a little bit of openness in the specification, but in the end, we define the output data, and that's what we focus on in the data model work for now. So let's talk about data. Yes.
We have Egge in the queue. Is it okay to take questions, comments
sure.
now?
Yeah, so we also had this discussion regarding properties that are observable and events. And for now, like the way we sort of like not really solve, but we first of all leave it to the developer, but as a feeling, so to say, is that generally the events are things that you like need some sort of a more configuration to set up. So like some sort of like subscription payload that you send and like set up some sort of a delivery mechanism. And then whereas in properties, then you would need to add more like sort of information into how we would set up these things. So we leave this kind of heavy event streaming protocols to the event affordances. And also for observable properties, we sort of say that it reports only the changes to the property. So if you want to, let's say, send every second the position of a robot, whether it changes its position or not, we would like imagine it's like an event stream. So that was sort of like a discussion we also had at some point, and I think it might be also useful for you.
Okay, thank you. So yeah, it's interesting because properties actually, knowing that you have recent data about the property is different from not knowing anything. So I think you are missing some information in that modeling. But let's not compare the things. Let me try to explain what's there at the moment. And again, the point is that in the end, we come out at a data definition, and the data definition works by saying what kind of data should be there. So we have, of course, we all know lots of data definition or schema languages. And data definitions can, if they are simple, be just put inline in an affordance definition, or you can put them separately into the specification because it's used by several affordances and you don't want to repeat it everywhere. So right now, the data definitions in SDF can use a subset of the JSON schema org terms they have in their validation language, and they also can use some SDF-specific terms. So for instance, you can say that the data has a particular media type or content format, as we call it, or you can say that data are nullable, have certain scale limits, and so on. So that probably requires a little bit of a longer-term discussion how we actually evolve these data format elements. Right now, this is pretty much based on what we found we could immediately use. I'm saying this from a academic point of view, from a practical point of view. We have a pretty good set of terms right now, so we can do work. But it's not really a set of terms where you would say, oh yeah, obviously that's the way data definition should be shaped. So I expect some evolution there. So from these components, from the data definitions, from the affordances that actually make use of these data definitions, we can build objects. So objects are just combinations of affordances. So it just makes sense to have several affordances defined together. So if you have a thermostat, you might want to have a writable property for the set point, but you might also want to be able to find out what is the current temperature, or is the heating on, or things like that. So there are several interaction affordances held by the same object. And these objects in turn can be combined into things. So the assumption is that it makes sense to reuse object definitions in things, and I think that's something that many SDOs have. And things actually can reuse things. And I've put a little green thing here, insert magic, because we are still discussing how exactly to model a thing that's actually composed of multiple things of the same class. So if you have a smart outlet that might have a fuse, which you can read whether it's open or still working, you might have a switch, you might have several outlets which might have properties like current flow, and so on. And the way these objects are put together to a thing, that's currently still being discussed. But the point here is that we can build up a little library of objects that we actually can use to build things. And then in turn, ODM products are combinations of things that are not harmonized, but that what describes the specific products you can find out what SDF definitions govern the workings of that product. So I've talked about the specification in abstract terms. The concrete specification is just represented in JSON, because that is the best way to actually handle the specification with tools. And these JSON documents are linked together with JSON pointers. We use JSON pointers also to point into specific documents, also for internal references in such a document. And the fact that you can point to things means, of course, that you can reuse specifications from other elements, from other specifications. And one thing that might happen soon is that we define something like a basic call set that every specification can reference. So these would be common reusable definitions. So SDF, of course, is something that needs to be specified. And since SDF specifications are JSON documents, we can again use a data definition language. to define how these JSON documents look like, and that's currently using the JSON schema org terminology. So it's really important to be careful not to confuse the use of selected JSON schema org terms within STF with the way we describe the syntax of the format. In addition to the syntax, of course, we need semantics, and that's currently just a text file and actually a markdown file to make it easy to collaborate on that. And there's also a nascent best practices document that will define not so normative parts so people know how to best use this. So, of course, in reality, when you develop something, there's also a lot of knowledge about the semantics and the way things work together in the tooling that is being used. And it's really useful to look at the tooling that is used by the One Data Model playground. There's a little continuous integration system there that calls a program that looks at every SDF specification actually using two different JSON schema org style specifications and also looks at other things like file names and so on. The next step, okay, I forgot I have one more slide. So right now we are in a situation that we think the specification is stable enough to submit data models. So we reached that stage in Stockholm in October last year. So several hundred data models are now collected at the playground. And more importantly, the ecosystem SDOs have started developing tools to convert their corpus to SDF. So many of the examples in the playground are from these tools. Right now, the OCF specs are missing because there's still a little bit of work to do to make them work again, but I expect a few more will be in there quickly. And the use of tools is really important to make sure that we have good coverage without creating enormous amounts of work. So we have these data models coming up, and we are learning a lot about what data models actually need. The specification itself also needs some cleanup. So in particular, the natural language part of it needs an editorial round. And we are looking at a 4-day online conference in the first weeks of May to actually do this kind of work. So originally we planned a face-to-face. That's not going to happen. And in order to get the work done, we will have 2-hour slots distributed over 4 days. So we make some progress. And the whole thing, I think, should be completed by the end of May. Last slide. So what are we going to do next? I said we're going to fix the language and so on. But I think the really interesting work is now to get tools done on the model consuming side. So we know how to produce these models, but that doesn't give us a lot of certainty that these models are actually useful. So we actually have to do work now building tools that consume these models and do something useful based on the information extracted from those models. So this is one of the points of the Wishy hackathon. And I think one of the fun parts will be seeing how SDF and W3 what thing descriptions can be combined to make this useful. So thing descriptions have all these things like protocol bindings and so on that SDF actually doesn't have. So it makes a lot of sense to work with those together. Yeah, so a few things need to be solved to get something like an SDF 1.0, which would be an output of that liaison group. We can use those playground definitions to serve as a corpus in solving these issues. And one of the interesting thing of aspects of having all these models in one place is that if we make a non-backwards compatible change to SDF, we can just go over all these definitions with a tool and change those definitions automatically. So we don't have to be quite as afraid of doing non-backwards compatible changes. So for instance, we had a rare spelling of the word writable already in a previous version, and we have fixed that, and we could easily fix that because we could just run a tool over all these models. So this is something that will be done in the spring, early summer this year. And then, of course, the next question is how do we turn SDF into a real world specification? So we probably want to find a venue for standardization, and typically the IETF comes up as a potential venue there, and those are discussions that now need to be held to find out whether the IETF is the right place to do this and actually wants to do this. Questions?
Hi, Carsten. This is Mohit. So I think this all makes sense. Who do you think would be doing the like if I am part of this ecosystem, what's the motivation for me to like publish this in SDF? And then who would be then doing the proxies?
Well, the motivation for publishing the ecosystem's specific specifications in SDF is that you want other people who are rounding out their ecosystems with specifications for the things that you already have stay compatible to you. So you are kind of the opinion leader for this particular kind of thing. I think that there's tangible value for that, and one of the reasons why the ecosystem people are so interested in making their specification available quickly. So how do you actually work in this space? Well, as I said, right now it's a liaison group, so you have to be affiliated with one of the ecosystems to actually join the actual 1DM meetings. But since the work is happening in the open, you can just send a pull request to the playground and submit things, and you can be sure that other people will be looking at that and give you feedback.
As I understand, that doesn't answer the question about who is doing the proxies yet. Sorry, Christian.
Well, again, the people who are working in the specific ecosystems and are trying to make their specifications maximally useful. These are also interested in doing the proxies. First of all, of course, to test out the SDF specification itself. Do we have everything in there to build a proxy? But also to validate that the ecosystem-specific side actually can be done and nothing is missing there. Does that answer your question now?
Yes.
Thanks.
I would kind of have expected an answer that says that one proxy would do this all from the specifications, but of course this won't cover the protocol specifics.
Well, you have to have protocol bindings for the specific ecosystem. So it's quite different to switch on a Zigbee light than to do it using CoAP. So of course there are those proxies already. So IKEA sells a box that speaks CoAP on one end and speaks Zigbee on the other. I'm sure that the people who build these proxies will also enter the work at some point. But at the moment, really, the pushes from the people who have all these hundreds of data models and want to make sure they work globally in the world of IoT and not just within the ecosystem.
What we're doing for the demo is we're using or planning to use the View 3C Web of Things implementation in Eclipse Foundation called ThingWeb Node Watt, which has protocol bindings protocols that we're using already. So we're basically planning to use the SDF model with creating a subscription-free the proxy that has its protocol binding that describes that protocol, and then sort of do the work inside Node Watt, if you will, to do the actual proxy conversion by property or whatever we need to do.
Good. Thank you, everyone. It's very good discussions, but I'm afraid we're running a bit short on time. So maybe Lars can prepare to present next. And for everyone who's more interested on this particular topic, I recommend you join one of our upcoming Wishy 1DM meetings. So even if the 1DM, let's say, core work is happening within the liaison group, that is not open for everyone, the work we do in the Wishy group is open for everyone to join, just like any other things in our research group meetings. So I recommend you join those and discuss this in more detail. Carsten, any closing notes before we move to Lars's presentation?
So that's pretty much the closing note I would have made as well. So I think the research group is a good neutral ground to do work in this space. And it's a fun research topic, I could say.
Absolutely. Great. Thank you, Carsten. Lars, let's go next. We are a bit behind the schedule, so if you don't need your full half an hour, that would be great.
Yeah, I can make no promises because I have way more time at NDSS. Right. How's the sound?
It's okay.
Okay, good. And I'll try to share this thing. All right, can you guys see?
Yep.
Okay. Right. So this is a talk about a paper I had at one of the NDSS workshops. I think it was called this, and then I also talked at the QUIPS workshop, which was on securing quick. So this is sort of the write-up of a little sort of side experiment that it was trying to figure out if you could actually run a quick stack on an IoT device. And so what I did is I basically got the two most featureful boards that I could find that also had Wi-Fi, because I wanted to make sure that I could run something, and sort of saw how that worked. And this is sort of the write-up of the outcome. I don't think I really need to really motivate why, right? A, this is a research thing, and B, right, if we could use Quick on IoT devices, or at least some IoT devices, we could sort of leverage all of the engineering that's being poured into Quick and for IoT, right? And I guess this would be a good thing. Most people would agree. It's also pretty clear that there's a line here in terms of device capabilities below which it's not feasible to do this, and we can argue whether it's feasible at all or not, but at least I could get it to run, as you will see. The two things are part of this quick stack, right? So on the left-hand side, Warp Core, this is basically it's an UDP IP Ethernet stack that I originally wrote on top of NetMap for data center networking purposes. So it's basically meant to be as fast as possible. So it bypasses the kernel, it writes straight to the NIC. It easily fills a 40 gig path with a single core with a single flow. It's pretty small, so it's obviously not fully standards compliant, but it can fake it enough so that you can speak to arbitrary hosts, or at least sort of mostly. So it's like 3,000 lines of code, and it's another 3,000 if you actually use NetMap, which we don't for these IoT devices, obviously. It also has a socket backend, which I use for 2 of them. And it sort of exports an API that's 0 copy, which is also nice because I thought that would be useful for IoT. It turns out the operating systems that I used, which were Riot and Particle, have no 0 copy sort of mode of operation, so that was useless. By the way, since I don't see the question queue, Ari, if you want to interrupt me at any point and see if there's any questions that people want to ask, or people can just interrupt me themselves, we can do this. Right, so as I mentioned, I got 2 boards. One is a Particle Argon, the other one is an ESP32. The Argon has Particle's what's called device OS on it, which has LWIP, which is nice, right? So you can basically just run this warp core thing on top of LWIP socket emulation, and that's good enough. Riot has this thing called GNRC, a generic network. I don't know what the R is for and what the C is for, but it's basically its own IPv6 stack, and it has a bunch of problems. Most of all, it doesn't let you wait until a packet arrives. There's no poll or select. It doesn't have IPv4, and unfortunately, the LWIP port, which exists for Riot at the time I tried to use it, was broken on the ESP32, and so I couldn't use it. So for the Riot implementation, I hacked together a very bad warp core backend that speaks to GNRC and sort of fakes poll and select in ugly ways. Right, so that's basically packet I/O. So this lets you send UDP, IP, and Ethernet packets. Quant is the quick stack. So this is a thing that I'm chairing a quick working group for those of you who don't know. And one thing that I quickly realized is I wanted to be sure that what we were standardizing was actually implementable, and so I decided I'm going to do a little toy implementation along the along the specification process. And that's been going on like for 3-4 years now, and I've been doing this since version like 7 or 11 or whatever. So it's come a long way. I would not recommend you use this for anything production related, but for playing around, it's fine. It's about 10,000 lines of code. When I did this experiment, which is a couple months ago, again, the focus of Quant is actually high performance data center networking. So I'm interested in how fast can I make Quick go. But it turns out because it runs over this warp core packet I/O background, it's actually reasonably portable to IoT devices. And it's not optimized at all for IoT, neither is warp core, by the way. But it turns out it's not terrible. So it uses a bunch of data structures that you normally wouldn't want to use on an IoT device. So it uses K-hash, for example, right? It uses timing wheels, it uses splay trees from FreeBSD, it uses bit sets, and it uses Kazuo's Pico TLS implementation, which is a reasonably lightweight TLS 1.3 only implementation that uses has 2 crypto backends. One is OpenSSL, which obviously doesn't make a lot of sense, but it also has what Kazuo calls mini crypto, which uses Cifra and micro ECC for the crypto operations. So it's not terrible. And so I wanted to sort of figure out, can I run this thing? This is sort of a little bit of a overview slide for those of you who don't know these boards. On the left-hand side is the Argon, on the right-hand side is the ESP32. You can see that they're reasonably powerful, right? So the Argon has a ARM Cortex M4 with floating point. It runs at 64 megahertz, right? It has an FPU. It even has an ARM trust zone, which for the measurements here doesn't matter because it's not exposed by Particle to user applications, so I can't use it from Pico TLS. It has quite a bit of RAM and quite a bit of flash, and again, this was because I wanted to make sure I could run something, but I didn't want to like do the work and then realize I got the wrong board to actually run something on. And it does wireless LAN. Why? Because also easy experimentation. On the right-hand side is an ESP32. I guess most people have seen these. Again, it's pretty powerful. It comes this Argon device OS is FreeRTOS based, and the normal Espressif development kit is the same, right? But I didn't want to compare like 2 FreeRTOS based systems, so I decided I'm going to run Riot on the ESP32 just because it's supported, and to get a little bit of a different operating system in there to see if it makes any difference. So I used Riot as of the release from last October. Both of these tool chains are pretty old, right? Given that GCC 9 is out. And we'll see that that there's some issues with link time optimizations that don't work for both of these, which might have made the footprint a little bit smaller. So those are the boards. Right, so measurements. So maybe now would be a good time if there's any questions about anything I've said so far. All right, I guess not. Let's look at the measurements. I'm basically gonna first talk about sort of the code and static data size, meaning how much flash do you need to consume to run Quick and TLS 1.3. So I'm gonna do a baseline build first. So this is basically, so both Quant and Warp Core have a bunch of things that sort of are already pretty small in size, right? So they already, if you just compile them, you can get them to use just under 100 kilobyte of flash, which is great. So I'm going to show you two stack diagrams. On the top bar graph is the Argon numbers. On the bottom is the ESP32 numbers. And the bar graphs have like three major colors, right? Green, red, and purple. Green is the size of the TLS stack. Red is the size of the Quick stack, meaning Quant and Warp Core. Purple is the application. You'll see here that the application for the Argon is a little bit bigger than the application of the ESP32, which you can't see at all, really. That's because on the Argon, I had it first and I had more time with it, so I stuck some stuff in there that turns on the LEDs and makes it reply to button presses and so on. So there's a little bit more application code there. Basically, all the application does is it does a get for a 5K object to a web server, an HTTP3 server that's running on my laptop. And you also see that there's sort of dark and light green and red. So the dark red is Quant, the Quick stack. The light red is Warp Core, which is the packet IO. And obviously, the majority of that red is going towards the Quick functionality. Packet IO doesn't really need a lot of bytes for the code. For the TLS stack, the dark green is the TLS 1.3 stack. And the darker of the light greens is Cifra, and the very light one is micro ECC. So you can see that about a third of the TLS footprint goes towards the crypto operations at the baseline, which is quite substantial. So if you could use the hardware crypto that's available on both chips, you could already save a whole bunch of space right there. But that's the baseline. So we compile them, and for both of those platforms, you end up just under 100 kilobyte for something that runs and downloads an object over Quick, which is not terrible already, right? But let's see what we can do. So the first thing I did is I did some 32-bit optimizations because neither of those chips is 64-bit, and Quick really wants you to run on a 64-bit platform. It has a bunch of arithmetic that is sort of 64-bit math. The nice thing is you can avoid most of them, right? So the most expensive thing is division and modulus, which you can sort of eliminate my code at least because it's all by constant. So you can, some bit tricks and you can get rid of that, which is nice. It saves a few kilobytes. I'm using 32-bit widths for a whole bunch of internal variables for Quick that are, 64-bit wide in the specification, like packet numbers. But I chose to just use 32-bit widths because on an IoT device, right, how likely is it that you're going to send more than 2 to the power of 32 packets over a single flow? Practically zero. And that sort of already brings down the code size by like 5K, let's say. So that's pretty good, right? And we haven't given up much sort of standards compliance, quote unquote, yet. Next thing, so Quant by default is a server and a client library. So you can run, both at the same time if you want to be a proxy. So I made the assumption that on an IoT device, maybe you just want to be a client, right? I don't really see a need to run a Quick server on an IoT board. If people want to do that, you can measure it. I haven't, right? But if you are basically dropping server mode for both TLS and for Quick, you get a really big savings, right? You're going down to under 80K, 75K for the ESP32. So you can specifically see that the TLS savings are quite substantial. You're almost gaining like 10K, just getting rid of all that server-side TLS processing, which is quite nice. the other thing that does, so Quick has this mode where you can use zero-length connection identifiers. And if you're a client, and if you don't expect to be switching network attachment points, it sort of makes sense to use this. And in client mode, I also enabled that. So the savings at the Quick layer are actually due to using exclusively zero-length connection IDs. It lets you eliminate a bunch of structures that are used for matching packets to connections based on a connection identifier instead of IP address and port. Next thing, right? TLS 1.3 has a whole bunch of crypto things, crypto algorithms that are sort of mandatory and or suggested or what's the RFC 2119 term? Recommended, whatever. So if you're, as a client, right, as a server, you do want to speak all of them. As a client, you can sort of choose not to and still interoperate with all servers, which is nice. So basically, I'm leaving AES 128.256 as a cipher suite and one key exchange. Why AES? Because Quick uses that for packet protection already. So if you want to speak Quick, you need to do AES to protect your packets. And so it makes sense to use the same crypto also at the TLS layer, right? We can have an argument about whether, something lighter weight than AES or would be useful, like something elliptic curve, but this is the reality at the moment. Because packet protection is only that one cipher, you just will use the same one for TLS. So we're getting more gains at the TLS layer. Now specifically, we're getting quite a few gains also at the Cifra and micro ECC layer. We're down now to 27 to 26 kilobytes for TLS 1.3, which isn't terrible, right? And as I said, if you could use the hardware crypto, you can eliminate the bottom half, the two light green bars, and you could, get some more reduction. And sort of this is saved compared to the baseline between like 25 and 30% already, which not a whole lot, much loss in functionality. The next few numbers I'm going to show you is if you disable more stuff, but you give up some things in terms of functionality or spec conformance. So Quick has this thing called connection migration, where if your net rebinds or you want to switch from one interface to another interface, you can do that and the connection survives that. That I would claim is sort of unnecessary for IoT use. So if you turn that off, you get another few kilobytes of code reduction at the Quick layer. Sort of Quick has connection close frames, and they have a reason field that you can take arbitrary text. And Quant by default is quite verbose in using that. So whenever it sends you connection close frames, it puts like a string in there. It says, here's why I closed your connection. And obviously those need to go into the static image somehow. So if you don't do that, then they're not for protocol usage. They're only there for like human admins to look at. We don't do that. We save another few kilobytes because we don't need to carry those strings. Quick has a feature which is a stateless reset, which means that I can tell you I'm going to send, if I've lost state for a connection that we had, I'm going to send you this random number instead in some way. And that is for you a signal that I don't know who you are anymore. And obviously I can compute this thing based on the packet that I see coming in from you. So that lets you basically drop state too, rather than keep retransmitting and eventually timing out. But it's an optimization and you don't necessarily need to do this. So if you eliminate that code, it's another 1 or 2 Ks that you are saving, but you're forcing the other guy to potentially retransmit more. So there's support for dealing with reordering in Quick. There's sort of 2 things that you want to do. There are 0 RTT packets, which are, if they're reordered, it would be nice to cache them so that when you have the keys for them, you don't need the peer to retransmit them. So you need to store them in some data structure. And if you don't do that, you have more gains, but potentially you have a little bit of a drop in performance if there's reordering. And you can just drop all reorder data rather than keeping it around to deliver it when it's in order. And that again forces the peer to retransmit that, but lets you drop some data structures again. And so this is sort of the final thing that I did, right? So you can see you can run this thing now in 63 kilobytes to 58 kilobytes for the ESP32, which is actually quite good, right? So in around 60 kilobyte, you can get a full TLS on 3 stack, including software crypto, and you get a quick stack. And I should have said earlier that Quant does not implement HTTP3. So it implements sort of a TCP TLS-like protocol. It's a transport protocol, but it doesn't do HTTP3. So if you wanted to actually do HTTP3, you probably add a few more kilobytes for an H3 stack, which I haven't done. There's some other things that I did. Oh, there's one more. So there's also this TCP-like connection information structure that Quant by default keeps around. So you can see like what happened to this connection, how many frames were transmitted, how many packets. And if you don't want that on an IoT device, you likely don't, you can compile that out and you're gaining a little bit, not a whole, or not even a whole kilobyte. And that's my final slide on this. So that's it for the static sizes. What about stack and heap usage? So again, I'm going to show you the same two sort of diagrams. This time they're not bar diagrams, but they're actually just dot plots. So I instrumented the binaries to log stack and heap usage whenever a function is entered and exited, and specifically log this out over serial. You can imagine that gets very noisy very quickly, and it actually became so noisy that it didn't terminate in any sort of sane amount of time, like less than a day. So I dropped instrumentation of the crypto functions. One, because you could argue that if you had hardware crypto support, you wouldn't execute those anyway. And they're very frequently called, and they have very many small functions. So what I show you on the right-hand side is actually the lower bound of the stack use and heap use. No, specifically stack use, because I don't go into those functions. And I'm not showing time units on the x-axis, and that's by default because I'm actually exporting this over the serial line. So it's meaningless, right? It takes sometimes an hour or two to do one of these runs. So there's no performance to this. Just look at it as time. There's sort of, and I've removed random 20% of the data points to make the overplotting a little less severe, so you can see a bit more what's going on. There's there's 5 phases to these graphs, right? There's a dark red, which you can barely see on the very left, which is the the initialization phase. You can see it a little bit better on the ESP32. The initialization phase on the Argon is much shorter because on the Argon, the application, quote unquote, gets started once the device is attached to the base station, while on the ESP32 under Riot, that thing already counts towards the application runtime. So you can see these few sort of dots that are there in the init phase on the bottom graph, which is when functions get called while the thing is trying to find the Wi-Fi. So that's pretty flat there. The interesting thing is during the open phase, right, which is when you're actually opening your quick connection to the server, and you can see that that's really when the stack usage is highest, and it's pretty bad. It's certainly reaching 3 kilobytes, and since I don't plot the part in Cifra and micro ECC, it's actually worse. It's actually over 4 kilobytes because those have quite a few stack hungry functions that they use, which is pretty bad. On device OS, the default stack is 6K, so it's actually okay to run. On Riot, it's 1K, so it crashes. So you need to compile Riot with a larger stack to make it run. So that's pretty bad. And part of that is due to Pico TLS, which has a bunch of functions that also use large stack allocated variables. And part of it is also, as I said, due to this public key crypto stuff, which is not super great. And you can see that the public key crypto is worse than the symmetric key crypto because during the green phase, which is the data transfer phase, the stack utilization is way lower than during connection open. which is nice, but you can't buy anything for that because the worst thing, or the thing that actually matters is the worst case. You don't get a cookie for using less stack on average. And doing connection close, again, ramp down. So it's not super great, but stack usage could certainly be improved. And I was quite surprised that crypto libraries like micro-ECC that specifically claim that they are meant for embedded devices then use a couple hundred bytes of stack allocated space. Anyway, but if you could use the hardware crypto, that wouldn't happen. So I actually went through all of this already, so I'm going to just zoom through these. Heap usage. So this is again over the runtime, and you can see that in the initialization and close, there's a little jump there in blue. In heap utilization, that's because Warp Core uses statically allocated packet buffers, and that's where they get allocated. And for this run, we use 15 buffers at 1500 bytes, which translates to that arrow there. One thing you'll see is that the baseline heap usage on the Argon is somewhere around around 96 kilobytes, while on the ESP32 it's below 32 kilobytes. That's because device OS actually in the background in another thread has a full thing running in parallel to the user application that connects the Argon to Particles Cloud and lets you do firmware updates and do all kinds of stuff. So, and that obviously has a footprint, both in terms of not having as much flash available as you think you had when you bought the device, and you also don't have as much RAM or heap as you think you should have, because the device OS takes its chunk. Otherwise, sort of what's notable is that during the open phase, right, the heap is slightly increasing, but it's not terrible. There's no large jumps. And that's because a whole bunch of sort of per connection stuff gets allocated. Ideally, you want to have all of that statically allocated, but because this is not IoT code, I have dynamic memory allocation, but it's not terrible. And during the transfer phase, what's nice is it stays flat, right? So no spikes, which is great. And then stuff gets deallocated and you're out. Finally, energy and performance. And I should say that these are probably the hand-waviest measurements I've done. So the energy measurement was only done for the Argon. That was because I didn't have a battery for the ESP32, and I don't even know if it has battery pins. I got it so late that I couldn't play with it much. So I had one battery, which is a 2000 milliampere LiPo battery. And I did exactly 2 runs, and that's because each run took like 3 days or something like that. So I charged that thing fully, as close to at the same level as I could manage, and then I'm basically have the client run a series of GET requests for 5K objects, one after the other until the battery runs out. And what I'm reporting is the self-measured, I should say, voltage of the battery. The Argon can measure its own voltage, and there's a whole question about how accurate that is. But it's sort of, it goes down over time. There's 2 runs. I wanted to see whether quick 0 RTT connection resumption makes a difference. So blue is everything runs with 1 RTT handshakes. Red is you run exactly one RTT handshake at the beginning of the connection or at the beginning of the run, and every subsequent connection does 0 RTT connection reestablishment. This ran for 2.5 days, as I said, and we get just under 30,000 1 RTT connections out of the battery before it dies, and just under 32,000 0 RTT connections. So there's a battery benefit to doing 0 RTT, which shouldn't be surprising, since it eliminates some processing from the handshake, and so saves some energy. But it's very preliminary, but I wanted to include it because I found it kind of interesting. Performance was measured during the same run that I just showed you the energy measurements of. So for each of those 30,000 and some connections, I took the time, and the median 1 RTT connection took about 5.1 seconds, and the median 0 RTT connections took about 4.74 seconds. So it's 0.35 seconds faster to do 0 RTT, which is nice. There's some open questions around this. Sort of if you look on the graph there, 0 RTT does show a little bit more of a slope compared to 1 RTT, which is pretty much a straight line up until the 80-90th percentile. I don't know. I need to look at why this happens. I would have actually expected the opposite, but there you have it. And 1 RTT is sometimes faster. If you look at the very bottom, right, there's the lines are crossing, and that I don't quite understand either. So there's some future work here. There's actually quite a bit of more future work. What's my time? Lots, right? So in terms of measurements, data upload isn't done. There's almost no varying of any parameters of these measurements in terms of object sizes, streams, connections, and so on. We're not comparing against anything else, right? Neither TCP nor TLS nor CoAP nor something else. There's nothing about different boards or different operating systems. The energy measurements are pretty rough. On the implementation side, there's lots that could be done, right? I said I don't do HTTP3 at the moment. That could be included. Pico-TLS could be improved quite a bit. Better data structures could be used that are sort of more optimized for IoT usage. Hardware crypto, I think, would be the highest on my list, actually, in terms of performance and energy savings. Do we actually, what if we just didn't do 0 RTT? Could we shrink down the code size more? I would be interested in looking over to IP over BLE or 802.15.4 instead of wireless LAN, just sort of as a cookie, right? So on the ESP32 with Riot OS, the wireless LAN driver is 115 kilobyte, which is 45% of the stuff that you need. So 45% of the entire size of Riot is for the wireless driver for the ESP32. So I'm hoping, for example, that BLE or 802.15.4 have sort of saner drivers. And the question is, can you actually scale this down to smaller devices? And my gut feeling is you probably could. If you were to build a quick implementation from scratch for IoT, you could probably do it in half the space that I use, sort of maybe 32 kilobytes or something with TLS. And that I think would be pretty cool. And that's all I had. Thank you. Questions?
Thank you. Mohit is first in the queue.
Hi, Lars. Thanks for this excellent presentation. As chair of LWIG, of course, we would be happy to host this work there at some point when you wish to bring it there. So some technical comments. I think even though maybe some of the REST community will disagree, but I'm fine with this, that the IoT device is a client that initiates connection. But then you're also saying that maybe 0 RTT isn't so useful and we can drop that. Whereas I would argue that if the device is the client, then 0 RTT makes sense to have it there, because like the amount of energy sent or consumed for sending any packets or receiving any packets on the radio is much more than energy that you spend on doing local computation. And if you can save on receiving and sending packets, even at the cost of doing some extra computation or having some bigger flash size, that's my gut feeling is that's probably better. So yeah, I agree. I'm not sure we should drop 0 RTT. I think we should do that. Second comment, this hardware crypto, of course, if the board provides support, we should definitely use it. Just to get an idea of how far can you go if you have hardware support. And then the third, I guess your future work was saying about 16-bit. I wouldn't do that. I think it's almost very hard to find 16-bit microcontrollers. So, and I mean, there's no point. I think the 32-bit ARM Cortex M3 are sometimes more energy efficient than any 8 or 16-bit microcontroller. So I don't see any point going down that path. And of course, yeah, BLE or 15.4, quite happy to see results on that in the future.
Thanks.
Thank you. So Thank you for this presentation, Lars. Mohit, you are next.
And for the upcoming presentations, if we can steal 3 to 5 minutes away from each of your time, then we might be able to still end this on time.
All right, I will try
This is
to
slide.
I will try to take less time than I was allocated. Do you see the slides?
It's starting to share.
I see a blank screen. That might be the WebEx bug again. Does anybody else see those slides?
No.
Starting to share.
Mohit, can you cancel and try again?
Sure.
If it doesn't work, I can share your slides.
Do you see them now?
Yes.
Yes.
Excellent. Excellent. So yeah, hi. I'll be presenting this draft on secure IoT bootstrapping. We are on version 8, but the last few versions we didn't really update anything in the content. They were just keeping the draft alive. And this version we have made some updates. This is joint work with my co-authors Bechet and Dan. So what's the goal of this document, or what's the new goal of this document? So before we were just trying to kind of document what kind of bootstrapping mechanisms exist, and there are plenty of them in the IETF and outside the IETF. So the goal of this document was just to document them. And of course, like then we had like more questions like what does bootstrapping even mean? How do you define bootstrapping? And there's a bunch of related terms that are used, for example, onboarding, commissioning, and so on, initialization. How are they related, and how are other people using these terms? So one of the goals of this document is just to see like what are the related terms and how they are being used, and possibly identify some common patterns and provide recommendations that perhaps maybe we at the IRTF or IETF should be using these, or favoring these terms over some other more obscure terms. And then, like, of course, we still continue with the original goal of providing examples of bootstrapping techniques. We will try to cover all IETF and several non-IETF protocols, knowing that, you know, we can't cover every bootstrapping technique that exists. And perhaps maybe try to see if we can classify them based on, like, do they require a server, do they require a smartphone application, and so on, like just to get a better feel for what are their requirements and assumptions. So I went through some of the specs, including OMA, OCF, a bunch of others, to see what are the terms that have been used in the specs, and this is the list that I had. It's not complete, so you know, if you find something that's missing, say now or mention on the list. So bootstrapping, provisioning, onboarding, initialization, registration, commissioning, configuration, and in the next few slides, you'll kind of see how some of these SDOs have been using these terms. But of course, I might be missing one or two. So one of the SDOs that we work with and are kind of interested in is the OMA lightweight M2M specification. And basically, I went through the spec to see what's the term they are using. And basically, a new IoT device needs to contact a bootstrap server, which is responsible for provisioning essential information. So they refer to the fact that a server is giving credentials to the device as provisioning. And once the device is provisioned, then it goes to the actual lightweight M2M servers and registers itself there. And later on, this lightweight M2M server will manage the client device. The specification talks about 4 bootstrapping modes. So there's factory bootstraps, smart card, client initiated, and server initiated. I'm sure some of you are familiar with these, but they are quite obvious. So in client initiated, the client is initiating the bootstrapping. In server initiated, it's the server. In smart card, there there is a smart card, and in factory there is like some things that are burnt into the device at the time of manufacture. But the two terms or the three terms that are used in OMA lightweight M2M is bootstrap, provisioning, and then registration or registers. The other SDO, another SDO that I looked at and perhaps you are quite interested in is Open Connectivity Foundation. And this SDO calls the process before a device is operational as onboarding. And the first step in the onboarding process is configuring the ownership of the device. So basically, if you have a new IoT device, you need to somehow configure who is the owner of this device, and they list a bunch of owner transfer methods, which is how you will establish a owner of a new completely blank IoT device. So there's the just works, which is kind of like Bluetooth just works. So you basically have an authenticated Diffie-Hellman exchange, and if there is a man in the middle attacker, then well, too bad. So it's not completely secure. Another mode they have is this random pin, where the IoT device is supposed to generate a pin and show it to the user, which the user will then copy onto this onboarding tool. And onboarding tool, even though they say can be anything, it can like run on any device. In most scenarios, it would be like a smartphone application. You could also use manufacturer certificate, though they don't really answer in the spec how. So like, yeah, a manufacturer certificate can say that this is a Samsung device with a serial number so and so. They never really say that you should also check that it's the same serial number that is shown on the box of that IoT device. So it's still some open questions. And then there's of course the vendor specific option, where they don't say like how it's done, but vendors can choose how they wish to establish the owner of IoT device. But the idea is that at the end of this process, there is a owner of this IoT device, and at the end of this new owner would provision or configure the device with owner credentials. So basically, let's say after just works, there is some kind of a session key, and using this session key, I will send new credentials that are that I provision or configure. And after this ownership is established, I would also send more information like where is your Bootstrap server, what are the credentials that you should use with the Bootstrap server, so on. But again, a mixture of terms. So there's onboarding, configuring, provisioning, and then there's of course this Bootstrap server. There's also device provisioning protocol. So this is a specification coming out of the Wi-Fi Alliance, and it describes itself as a standardized protocol for providing user-friendly Wi-Fi setup. DPP also relies on configurator, so most likely it would be a smartphone application, which would then help you in like setting up all your other devices, which are called enrollees in the network. And it has three sub protocols or three phases. So there's the bootstrapping phase, authentication phase, configuration phase. So here, like they use provisioning as the overall step, and then inside provisioning you have bootstrapping, authentication, and configuration. The bootstrapping step, you scan QR codes or tap NFC. You run some protocol, and then you configure new credentials such as the SSID and passphrase of your access point. There's Z-Wave. I won't really go into details of how this works. It's on the slide. Perhaps you can look at it later. But again, similar idea that you have some kind of key pair, and you have a QR code that you scan potentially with a smartphone, and then there is some kind of elliptic or Diffie-Hellman key exchange. So some similar patterns. Doesn't really go into the terms that much, so they don't really use any of these common terms like provisioning, onboarding, bootstrapping, but rather just prescribe what the device and the controller should do. So what are the common patterns that at least I observed when I was going through? So it's a multi-step process. So this to make an IoT device operational, there is several steps, and different SDOs call them by different names, but they all tend to use asymmetric key pairs and kind of a secondary device or tool that helps you in bootstrapping, typically in the form of a smartphone. Not necessarily, some of them allow you to bootstrap without having this smartphone, especially if you have like thousands of devices. But for most scenarios, they assume that there is a tool or a device that assists you. Personal opinion, I think we should just say bootstrapping is the overarching term, and then there are various steps inside bootstrapping, whether it's in authentication and then followed by some sort of configuration and provisioning, and perhaps eventual ownership transfer. So in the next version of the draft, I plan to include the IETF protocol. So in the current version, I only had what other SDOs are doing, but I plan to include how some of these terms are used within our own specs at the IETF. So how is enrollment used, and Bruce key, and what is SZTP using, so on, what's EAP using. That I plan to add in the next version of the draft. The classification exists from the previous version of the draft. It's hard to classify bootstrapping methods, but generally you can have these 4 categories. So managed methods is where you have some sort of a server. P2P or ad hoc would be some. Sorry, I'm hearing someone's phone. It's not mine. Then you have P2P ad hoc methods, opportunistic leap of faith methods, and most of the methods are actually hybrid. So they might use initially like some kind of ad hoc setup where you pair with your smartphone, but eventually use a central bootstrap server. So yeah, it's hard to classify, and most of the methods are like some hybrid where they use components of both. One thing that I would like to cover in the draft, and I think which is important and fundamentally affects the bootstrapping process, which we haven't looked at into too much detail, is how do you do device reset and ownership transfer? Because many of the bootstrapping protocols just assume that if there is a new owner, you just need to factory reset the device. And in some cases, I'm not sure if that's the best idea or is even sufficient. And to give an example, for now on, you can't really reset Android, factory reset an Android phone unless you know the Google account, which is there on the phone. And this is like a preventive mechanism. If your phone gets stolen, then the thief shouldn't be allowed to just factory reset and start using your phone. But of course, like, what if you had legitimately sold this on a flea market, but forgot to factory reset it yourself? So should the next owner like go around looking for the previous owner? I was also surprised to see that some of these devices actually require you to have physical access before you can revoke any like keys or network access that you had allowed them. So at least I saw this Fibaro flood sensor requires you to press a button to remove it from your network. I was wondering, if I have already sold it, how do I go and do that? They actually require you to press the button while it's next to your controller or smartphone, which I find it like weird. So this is something that is often overlooked, but fundamentally affects the bootstrapping process and protocol, and is something that is worth looking at. So what's the status? It's on my personal GitHub, and I'm open to receiving pull requests and issues on GitHub or on the mailing list. Both are equally welcome. There have been some comments in the past on this draft. I hope there is more comments in the future, and at some point, perhaps we slowly move towards adoption by the research group. That's it. Any questions?
Thank you, Mohit. And while we see if there's more questions, Thiru, can you get ready, share your presentation, and you can
sure.
do it in very brief fashion, like 5 minutes. That would be great. And then we can maybe have a look at if in a later meeting we should have a longer slot for this.
Sure. I'll try to cover it in 5 minutes. Yeah. Can you see the slides?
Yes. So if there's no questions for Mohit, please, Thiru, go ahead.
Okay. Hello everyone, I'm Thiru. I'll be presenting our draft TLS profiles for IoT devices. This draft extends MUD. MUD is Manufacturer User Description Specification to describe TLS interactions. MUD as such, it's RFC 8520, which defines L3, L4 ACLs for permitting intended behavior for IoT devices, because IoT devices typically have a specific purpose. What we have been seeing in the last few years is malware has started using TLS. More and more malwares that are coming every year are using TLS, and very few malwares are now using clear text. But we see a lot of differences between the way malware uses TLS versus what we see TLS used by legitimate software. For instance, we see the domain name, the subject name indicator quite different from the subject alt name. Malware uses domain generation algorithms. The cipher suits and TLS extensions used by malware is quite different than what is used by benign software. Malware also uses self-signed software. We're providing IoT security for several IoT devices, and what we observed is that many of these IoT devices do not follow the best current practices. For instance, we're seeing IoT devices which are using expired certificates, are using weak cipher suits, and many of these IoT devices come hard-coded with the same private keys. And we also see that many of these IoT devices are vulnerable to server certificate validation, which makes them susceptible to man-in-the-middle attacks. For instance, a few years back, Samsung had a vulnerability where it was subjected to MITM attacks because it was unable to properly validate the server certificate. The key benefits of MUD TLS profiles are that it can define TLS profiles for IoT devices that have diverse communication patterns. It works for IoT devices even after learning new skills that change their communication patterns. And it also helps to protect IoT devices which have inadequate certificate validation, which may make them susceptible to MITM attacks. So as part of our investigation, what we had done was we have profiled several home network IoT devices, and we observed that the TLS profile parameters did not change even after learning new skills, though the domains that they talk to change. And these IoT devices have constrained TLS usage patterns. And the TLS profiles, even for IoT devices based on device type, manufacturer, and model, was quite different. And we also observed the TLS profile parameters of thousands of malware flows from McAfee Labs. And we identified that there's quite differences between the malware flows and the benign flows that we see from these IoT devices. And we identified that the malicious TLS use can be identified and blocked. So as part of this draft, we extend the MUD Yang model to include the observable TLS profile parameters. The TLS profile parameters is defined once for use, and TLS profile can also be defined specifically for specific destinations. For example, firmware server using a specific private CA. So that way, the CAs could also be specific to specific destinations. I have various examples here. I've listed Google Chrome as an example to show you how the cipher suits used by benign flows on Google Home is quite different from the cipher suits used by malware flows. And the protocol versions were also different, that a malware was using prior TLS versions and the benign flows were using TLS 1.2 and higher. The number of extensions were also different. Extension types differed. Groups and most of the parameters, we saw quite a bit of differences between the way malware and benign flows were behaving on Google Home and various other IoT devices, which help us conclude that TLS profile parameters can be defined, which helps us to identify and permit good flows and block the malicious TLS flows. And the bigger challenge for malware agents is that they won't be able to mimic the TLS profiles of several IoT device types and make and model coming from several manufacturers, and they won't be able to keep up with the updates to the TLS profiles. We also identified that even without acting as a TLS proxy, by just looking at the client hello, several of the malwares could be successfully identified. For example, we could identify a malware which was using cipher suit randomization, and that could be detected by just looking at the client hello message. Acting as a full-blown TLS proxy requires you to be compliant with the TLS proxy discussed in TLS 1.3 specification. It may or may not be possible in all the deployment scenarios. And just to conclude, I mean, we are looking for more comments and suggestions on the draft, and we would like to collaborate to profile benign and malware flows on IoT devices. Any comments?
Thank you, Kiro. That was very good.
Hey, I was just trying to finish it. Yeah.
Very
good.
First in the queue.
Hi. Thiru, I have three quick questions which I'll go in one go, and then you can see if there is time to answer. So one, this looks like IETF work, then IETF, but I don't really care where this work is done. It's up to you and chairs and other people. Second question, this seems like a typical cat and mouse game that currently malware doesn't use this kind of cipher suits, and you will start filtering them, and they would eventually move to the same cipher suits that is used by Google, or kind of the same parameters. So it's like a temporary cat and mouse game that we might win, but eventually I feel that they would use exactly the same protocol versions. I see there is no reason why malware would use TLS1 and not 1.3, or particular mode of AES and not the other mode of AES. So that's another thing that kind of worries me. The third thing, the measurements you have done currently don't cover the cases which will actually cause you problems later on. How often are Google devices moving from one version of TLS to another? And my worry is that when eventually they update the software or firmware, the profile would not be updated at the same time, because the mud profile is from this URL. So things might actually break when you start updating, like to a new curve or to a new protocol, because those things happen so rarely that there is no way to do coverage testing for that. So that's something to consider, that if it might break things.
Hey, thanks, Mohit. I mean, all are valid questions. So I'll just answer quickly each of them, and we can take it offline. So this draft is currently discussed in the operations and management working group. So the reason why I brought it to the research group was, since many of the IoT devices, especially the home IoT devices, don't support MUD, we were looking for a way to collaborate and profile benign and malware flows. The second question regarding malware catching up and exhibiting the same behavior as benign flows, yes, that's a possibility. And we have been, I work for McAfee, and we've been seeing the malware behavior for several years, and they always catch up. But the challenge here is they can't catch up in a way that they mimic the behavior of the TLS profile on each and every IoT device. For instance, the malware has to tailor itself so that they use the same TLS profiles. And from our observation, the TLS profiles for each of these IoT devices, even with different models, was different from each manufacturer. So unless the malware malware provider comes up with a way that he tailors his malware to be specific for each IoT device type, make it, model, it's going to be really impossible, because they typically use a rootkit, and it's going to be really uneconomical for them to basically suit and tailor their malware for each IoT device. The third question was, yes, this requires whenever a firmware upgrade happens, the TLS version may change. And OPS AWG is discussing a draft which discusses that whenever the firmware version changes, the URL gets updated and the new profile gets fetched from the manufacturer.
Excellent. Thank you, Thiru. And in the interest of time, we need to take the rest of the questions on the mailing list.
Sure.
But Xavier, you'll be next. Please go ahead and start your presentation. And we have quite a lot of, no, we don't have much time left. I'm afraid we might be going a few minutes over time, but still try to make it through the presentation. Please go ahead. Xavier, we don't hear you if you're talking.
Thank you, Ari. So I'd like to present the status of the draft IoT edge computing challenges and functions on behalf of my co-authors. So let's start with a short history of the draft. I will go quickly on that one. So we presented the first time in IETF 103, and there was a discussion in IETF 104 on Edge and IoT, in the T2TRG meeting, where this draft was considered a possible starting point for a group document to kick off this activity. So between this IETF and the next, new co-authors joined, and in IETF 105, we presented a renamed version of the draft. It was integrated with survey and gap analysis, so a presentation made earlier in T2TRG. So in IETF 106, we presented version 1 of this renamed draft, where the focus changed from use case examples to edge function analysis, and from one edge architecture to covering a range of models. So today I'm presenting version 2 and 3 of this draft. We reorganized the draft, we extended the background section and the list of functions. So in terms of updates, we made editorial and clarification edits in all sections, especially we kind of rewrote the abstract and introduction. We reorganized the draft, so now you have like 3 main sections. You have the background, challenges, and edge computing functions. And we extended the background section on edge computing to cover different understandings of edge, depending on people's background. The background can be in cloud, telco industry, or industrial automation. And we also expanded on the term fog to give it somewhat of an equal weight in this section. We extended section 5 to detail the list of functions, including detailed challenges. Functions, which are listed here on the left, can be present in some or all models, either centralized or decentralized. And the models are still covered at the beginning of the section 5. Functions are loosely classified as OEM, functional and application components. This classification, we are aware of that it's, it could be made better, or it's not always, what I mean is that it's not always very clear in some systems. Some systems will see more integration between these different layers, but it's not prescriptive, and its goal is just to be, to clarify the text. So we have this list here. Maybe I won't go through the list for the sake of time, but basically each section will describe this this function and some challenges associated to it. And we added a 5.4 on simulation and emulation environments. It's covering not only open source tools, but also the current ETSI MEC sandbox initiative, for example. So as a note for reviewers, so section 4 and 5 both have challenges, research challenges listed. Section 4 describes challenges on the IoT leading to the adoption of edge computing, and section 5 covers different types of challenges associated with individual edge computing functions. So we don't want to hold off any reviewers. So please, if you wish to review this document, please be aware that those are different types of challenges will be covered in different places in there. So we have also a short version 3 update that we made based on, in part, on some comments from Rute on the list. So we added several clarifications, including that end devices can be computing nodes, and also we expanded on the mobility support challenge. So this is the last slide. So we believe the draft is in stable state in terms of content and structure. There are still some areas we think need to be improved, clearly, but we would like to gather some feedback and base those improvements on the feedback from reviewers. So we would like to highlight just a few points for people who wish to review the doc. First, as mentioned in the last slide, please be aware of the relationship between challenges in section 4 and 5. Then the models we have for IoT edge computing in section 5 can be extended. For example, some of the co-authors have made some progress on distributed models, and would like to share some insights in there. So they will probably we will probably update that, but maybe after a range of first set of reviewers provide some comments possibly. And individual functions descriptions in section 5 can also be developed further for, especially in the detailed challenges. So for now, the level of the details in the section can be a bit unequal. Some sections have research challenges listed and some don't. We need to work on that, but also the input from the group would be greatly appreciated on this. Finally, the security-related contributions and comments are also welcome. So to conclude, the draft is now available for the research group to review and to consider for research group adoption. So questions I would like to ask to the chairs, is this a proper time to request research? What would be your advice on this? In any case, I'm done with the presentation. Thank you.
Thank you, Xavier. So Mohit is in the queue, but before we go to his question, could I ask everyone who would be interested in providing some review of this draft to send a +1 to the WebEx chat so we can gauge the interest? Just send +1. And Mohit, please.
I'm not in the queue. That plus Q was for the last presentation.
Oh, yeah, that's the same mistake we always make. Thank you. So, CoinRG, you are Marie-José?
I'm in the regal we today. I'm the CoinRG.
Thank you. Okay, so we have 2 people who +1 for a review. So I think we have to take this to the list. I think we do need a couple of reviews to assess whether this can go ahead as a research group document. I would want to remind people that when they write the reviews, the criteria for accepting something as a research group document is that we consider the work useful, not that we agree with every point of view that the authors have taken. So research group documents do not need to be consensus documents, they need to be useful documents. So if a document is a great way to document a view that is opposite to yours, you might still be interested to have it published as a research group document. So with that, I think we are done. Ari?
Indeed. Thank you everyone for joining, and apologies for running a few minutes late. And just a reminder, this was a summer meeting where we give a quick overview of variety of topics we're working on. If you're interested in working on the details, please join the discussion on the mailing list, join the upcoming work meetings that we always announce on the mailing list. Looking forward to see many of you contributing on all the upcoming activities in the future.
Thank you.
Thanks.
Thank you, everyone. Bye-bye.